Hello, this is Carol. Welcome to my mini presentation number 2. In this presentation, I would like to discuss golden ratio, which is a widely applied mathematical concept. I will focus more on its applications outside mathematics to show how universal math can be. So what is golden ratio? It is denoted as the Greek letter phi, and it's also believed as the divine proportion. It is one of the most famous irrational numbers, along with pi and Euler's number e. So mathematically speaking, as you can see from the image here, it can be geometrically represented. When one has a line segment being divided into a longer segment, which is A here, and a shorter one, which is B here. The sum of A and B, which is basically the length of the total segment, to A, the longer segment, is equal to A to B. So it's described here. Phi can also be written as a fraction 1 plus the square root of 5 divided by 2, which is approximately 1.618033, and the decimals just go on forever. So why is golden ratio so fascinating for generations? Well, Mario Livio, a famous contemporary Israeli-American astrophysicist and science writer, he comments in his book. So here's the title of the book, The Golden Ratio, The Story of Phi, the World's Most Astonishing Number. And the quote is on page 6. So he comments that some of the greatest mathematical minds of all ages, from Pythagoras and Euclid in ancient Greece, through the medieval Italian mathematician Leonardo of Pisa, and the Renaissance astronomer Johannes Kepler, to present-day scientific figures such as Oxford physicist Roger Penrose, have spent endless hours over this simple ratio and its properties. Biologists, artists, musicians, historians, architects, psychologists, and even mystics have pondered and debated the basis of its ubiquity and its appeal. In fact, it is probably fair to say that the golden ratio has inspired thinkers of all disciplines like no other number in the history of mathematics. So from this quote, we can see that the investigation of golden ratio can be traced back to Euclid's representative book, Elements, back in around 300 BC. Even Leonardo of Pisa, aka Fibonacci, connected his famous Fibonacci numbers or Fibonacci sequence to golden ratio. The properties of golden ratio have been mesmerizing thinkers across cultures and time indeed. So here's how Fibonacci numbers and sequence are connected to golden ratio. You can see the examples in the image here. So in sequence A or B, one can see that starting from the third number, it would be the sum of the previous two numbers. So here, as you can see that 5 is the sum of 2 and 3, 8 is the sum of 3 and 5, and then 8 is the sum of 3 and 5, and 13 is the sum of 5 and 8. So the golden ratio is found when the B sequence is divided by A, as you can see from here. So as the number grows bigger, the ratio of B to A gets closer and closer to the golden ratio. This finding can be applied to other Fibonacci sequences as well. So the golden ratio can be found in various fields, as many have found or claimed. In the nature, one can see the shape of many shells follow the golden ratio or the golden spiral. The eye of God, which is the tiny square in the center of the golden spiral corresponds with the eye of a hurricane, as shown in this image here. The number of petals on every layer of many types of flowers also follows Fibonacci numbers, sequence, and golden ratio. So what else? Let's move on to man-made world. Some art historians discuss how golden ratio influences our perception of beauty, especially when it comes to universally recognized famous paintings. Here are just some examples. In Rembrandt, the anatomy lesson of Dr. Nicholas from the Dutch Golden Age. So here's just a little bit background. The Dutch Golden Age was the peak of Dutch influence through trade, science, art, and military power upon the rest of the world. And it was about 17th century. So let's go back to the painting here. As one can see in the image, the position of the corpse lies just on the curve of the golden ratio. And as the viewer's eye gets closer and closer to the focus of the painting, you can see that the eye of God is just here, just the focus of the painting. Can we then argue that the golden ratio is applied across cultures? Well, the most famous painting in Japanese art might provide an answer. This is Katsushika Hokusai's Under the Wave of Kanagawa, which was painted during ukiyo-e, a representative Japanese art movement between the 17th and 19th century, right before Japanese comprehensive westernization in the late 19th century and early 20th century. Again, the wave movement in the painting appears to follow the shape of the golden spiral. Is it simply coincidental? We can move on to another conversation on Leonardo da Vinci's Annunciation. So some even argue that the position of these two figures just follow the golden rectangle. It is also worth noting that Leonardo da Vinci was believed as an advocate of golden ratio in many of his artworks. Perhaps the golden ratio is not only associated with classics. Well, Piet Mondrian's abstract painting in 1921 can be an instance to prove the cross-generational appeal to this ratio, as we can see from here. Here, you can even see the famous Greek architecture, the Parthenon in Athens, is believed to be built upon the golden ratio, according to the image here. Let's move on a bit to classical music. So in classical music, one can again find numerous examples. Here are just some interesting ones. So here, in the image here, the bass clef just resonate the Fibonacci or golden spiral, as you can see from here. And also on the keyboard, as you can see from here, the four notes here, C, E, G, C, which can be represented as the first, the third, the fifth, and the eighth note for C major. So the four notes here, they actually form a major C chord. And the intervals here, or the notes here, just follow Fibonacci numbers. So for example, 8 plus 5 equals 8. Even when we move on, some music theorists analyze Mozart piano sonatas and conclude that Mozart's music have been well received because the length of many movement, i.e. the number of bars just follow the golden ratio. So for example here, in a movement of 100 bars, we can see that for the exposition, that would be 38 bars. So the exposition is the beginning of the movement, and then the development and recapitulation. Okay, so the middle and the final part of the movement. The number of bars would be 62. So if we divide 62 by 38, voila, we get 1.6, which is quite close to the golden ratio. Even when we take a look at the structure of instrument like here, you can see golden ratio in a violin. Well, so how do I make sense of that? Well, growing up with classical music and have been passionate about music for over 25 years, I would say that I am quite convinced by the analysis of sonata form, because the form is one of the most organized structures in classical music, I would argue. I think that the transcendental beauty of this form properly resonates with the golden ratio, and such a resonance is not just a coincidence. So I think having appreciated numerous examples prompts us to ask a key question. Is golden ratio a myth or science? So I found a video on YouTube, well, originally on PBS, has an interesting investigation. So you can find the link here. Okay, you can actually take a look at this one. So the host challenges the viewers to wonder if the ideal body shape makes sense at all, or if all great architectural projects follow the golden ratio. Is it just a result of our tendencies to seek patterns in different things? In other words, are we biased by golden ratio in terms of differentiating the beautiful from the rest? It's also worth noting that the host argues that we actually dismissed the logarithmic spiral in numerous shells just because we are obsessed by the golden spiral or golden ratio. So at the end of the video, he experimented how plants grow in order to expose to the most sunlight, i.e. the arrangement of leaves. So he found out that the golden angle, so you can see from here, which is about 1/pi multiplied by 360, the result would be around 137.5 degrees. He said that the golden ratio would make sense for plant survival because the leaves would not overlap with one another. So they can actually expose themselves to the most sunlight as a result. All right, so after exploring all these examples in this presentation, what do you think? Are the ratio and the associated beauty standards artificial or just part of the mysterious nature to you? Okay, so this wraps up my presentation, and these are my references. Thank you for listening. Bye-bye.